So now we're going to look at analyzing data distributions. So when you have a set of data, you see how they're distributed. We're going to analyze what that looks like and what that means for us. So as we look at our first set of data, each x value represents one value. So we have 1, 1. There are 2 2s. We have 1, 2, 3, 4. We have 5 4s. If we were to write this out, we would write 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 6, 6, 7. If you can draw a line and see that the left side looks like the right side, then you have a symmetric set of data. If you draw the line, whether it's in the middle or not, and you see that one side is each side is just not the same. And in this case, we have the right side is taller than the left. We would say that this is non-symmetric. Symmetric, symmetrical, symmetry, same. It's like a mirror image. When we look at data distributions, we're also going to identify several things. We're going to look at symmetry, clusters, gaps, peaks, or outliers in all of the sets of data that we analyze. So let's talk about what those words mean. If it says identify symmetry, like the example above, they want to know, is it symmetric or is it non-symmetric? For clusters, they want to know, are there any groups? For gaps, they want to know, is there any open space? For peaks, they want to know the tallest point. What's the tallest part on the distribution? And for outliers, they want to know which ones are alone and away. Alright, so we're going to identify that information by looking, or each of those pieces of information, while looking at this data distribution. So the first thing that we see is it symmetric? The left side and the right side do not look the same. This is non-symmetric. Do you see any clusters, any groups? Not quite the same as on scatter plots. This is just, is there a group? I see a group right here. So I would say there's a cluster from 60 to 63. Next, they want to know about gaps. There are gaps between 58 and 60. There are also gaps between 63 and 71. We have open space there. Is there a peak? We have a peak at 61. That's the highest point. And are there any outliers? There's an outlier at 71. So this is an example. So now we're going to jump to the next page before we look at example B. There will be questions that ask you to describe the center and spread of the data. Well, how we find the center and spread is based on how the data looks. So we ask ourselves, is the data symmetrical? if you say, no, the data is not symmetric, then we have non-symmetric data. If you have non-symmetric data, you are going to use the median and to describe the center, and the IQR to describe the spread. So if it's non-symmetric, we would use median and IQR. If the data is symmetric, then we would use the mean to describe the center, and the MAD, the mean absolute deviation, to describe the spread. So this is something that you're going to have to memorize. But if we have symmetric data, we would use the mean and the MAD. If we have non-symmetric data, we would use the median and the IQR. So we're going to use that information to go look at example B. So example B. The graph shows the hours per week that dance students practice their dances. Describe the center and spread of the distribution. Justify your response based on the shape of the distribution. Round to the nearest tenth if necessary. So we're going to look at this and say, well, what type of distribution does it have? This is symmetric. Because it's symmetric, I know that I'm going to find my center by using mean, and I know I'm going to find my spread by using MAD. So we're going to calculate the center and spread. First, we have to write down all of our values from the table. So it says I have 1, 2. It says I have 2 3s. It says I have 3 4s. I have 5 5s. 1, 2, 3, 4, 5. I have 6 3s. 1, 2, 3. I have 2 7s, 1 2, and 1 8. So I wrote down all of the values from my graph. Sorry. Here are the values from my graph. Can I find the mean, the average? Sure. So add all my values. Divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And my mean, my average, is 5. So now I need to find my spread, my mean absolute deviation. I'm going to find the distance. Each number is from 5. So how far away is 2 from 5? 5 minus 2 is 3. 5 minus 3 is 2, 2. 5 minus 4 is 1, 1, 1. 5 minus 5 is 0, 0, 0, 0, 0. 6 minus 5 is 1, 1, 1. 7 minus 5 is 2, 2. And 8 minus 5 is 3. I'm going to average these distances to find my mean absolute deviation. So when I add those values together, divide by 17, I get that my spread, rounding to the nearest tenth, is 1.8. So it asked me to describe the center and spread, and we found that the center and spread were 5 and 1.8.